Yeah, hello friends, good afternoon. So I have come with one more problem today. So let's find out the coordinates of Centroid for SZ section. As you can clearly see here, it just looks like an alphabet Z, so I'm calling this one as Z section. Just I'm making it clear to you. The width of the section is 50 at the top, 60 at the bottom, and the thickness of the topmost flange is given as 20 millimeter. The thickness of the web is given as 20 millimeter again, and the thickness of this one is given as 30 millimeter here, and so the thickness of this one is 20, and the depth from here up to here it is given as 50 millimeters. So as you know very well that step number one, we have to assume that the entire section is in the first quadrant. So I'm just assuming that it is in the first quadrant. So my x-axis and y-axis will be like this. The x-axis will be exactly at the bottom of the section, and y-axis will be towards the left side of the section. Now the next thing is, just I'm assuming that there is a point capital C, x bar and y bar anywhere on the section. Let this be capital C, whose coordinates are x bar and y bar. Let capital C, x bar and y bar be the coordinates of centroid for the given section. So I don't need this right now, so I'm just erasing it off. And coming back to the third step, now we need to divide this entire section into three number of rectangles. Now the question is how to divide this entire section into three number of rectangles. You can do it your manner, but see that the section is divided into minimum number of rectangles, right? So I can divide this thing into three number of rectangles here. So how can we make it into three? Just I'm drawing a line over here. So this becomes the first rectangle. Next I'm dividing this one here. So this becomes the second rectangle and the third one. Now the dimensions of the first rectangle, so I'm just calling this one as the first rectangle, this is the second rectangle, and this one is the third rectangle. Now I'm writing down the dimensions of the first rectangle. So it has got some width b1 which is equal to 50 millimeter, and depth d1 which is equal to 20 millimeter. And coming back to the second rectangle over here, so it has got a width of b2 which is equal to 20 millimeter, and depth d2 which is equal to 50 millimeter. Next, coming back to the third rectangle, so the width of the section, right? So from here it is totally 60 millimeter. From here it is 60 millimeter, from which 20 millimeter is gone. The remaining will be 40 millimeters. So this is taken as 40 millimeter. So we have B3 which is equal to 40 mm, and depth of the third rectangle it is taken as 30 millimeter. As we all know that we can calculate the areas with these dimensions. So if I consider A1 as the area of the first rectangle, A1 will be equal to B1 into D1, which is 50 multiplied by 20, which is equal to 1000 millimeter square. So this is 1000 millimeter square. And next we can write A2, which is 50 multiplied by 20 again. This is again equal to 1000 millimeter square. And coming back to the third area, A3, which is equal to 40 multiplied by 30. This is 1200 millimeter square. So totally we have got three rectangles along with three areas, A1, A2 and A3. Now the third step is completed. Now let's go back to the fourth step. Now let us assume that there are three different points, C1, x1, y1. This is C1, x1, y1, x1 comma y1. Next we have C2 whose coordinates are x2 comma y2, and there is a point over here, that is C3, whose coordinates are x3 and y3. Now what are these x1, y1, x2, y2 and x3, y3? x1, y1 refers to the centroid of the first rectangle, where x1 is the distance from the reference y-axis. So this distance here it is x1, and y1 is the distance from the reference x-axis. So this is taken as y1. Similarly, x2 refers to the distance from the reference y-axis. This is x2, and y2 refers to the distance from the reference x-axis. So this is y2, and we have x3. So this distance here it is taken as x3. It is the distance from reference y-axis, and y3 is the distance from reference x-axis. This is y3. Now the question here is we need to find out c1, x1 comma y1. So as we all know that for the first rectangle the width of the section is 50 millimeter. The location of this point C1 from this axis y-axis will be exactly half of 50. That means half of 50, that is equal to 25 millimeter. So x1 will be equal to 50 divided by 2, that is equal to 25 millimeters. And y1, what is y1? Y1 is the distance. I'm just repeating the definition here. Location of this particular point, right? I mean to say the y1, it is the total distance taken from the x-axis. So from this point up to here we have to calculate. So it will be totally from here till here, it is 50 millimeter, and the remaining part is half of 20 millimeter. Remaining part is half of 20 millimeter. That means we are calculating it only up to here. This is half of 20 millimeter, that is 10 millimeter. Remaining is 50. So I can write this one as 50 plus 20 divided by 2. 20 by 2 is 10. 50, it is totally 60 millimeters. So we got x1 y1, which is equal to 25 comma 60 millimeters. Similarly, we have point C2, x2 comma y2. X2 is the distance from reference y-axis. So we can calculate x2 by subtracting half of the width of the second rectangle. I mean to say this particular distance. This distance will be half of 20 millimeter, that is 10 millimeter, from this 50. So this can be written as x2 is equal to 50 minus 20 divided by 2, that can be written as 40 millimeter. And y2 is the distance from reference x-axis. Y2 can be written as 50 divided by 2. So that is equal to 25 millimeter. I'm writing down C2, x2 comma y2, which is equal to 40 mm comma 25 millimeters. And we have point C3, which is x3 comma y3. So just I'm writing down the value of x3. X3 is the distance from reference y-axis, right? So I can calculate this thing. So total distance here, it is 50 millimeter. Up to here it is 50. From here till here it is 50. And the remaining half of 40 millimeter should be taken into consideration. So this is 50 millimeter plus half of 40, that is 20 millimeter. 50 plus 40 divided by 2. So x3, which is equal to 50 plus 40 divided by 2. So totally it is 70 millimeter, and y3 will be half of 30 divided by 2, which is equal to 15 millimeter. So C3 x3 comma y3, which is equal to 70 comma 15 millimeters. Now we all know the formula to calculate the centroid, right? Capital C x bar and y bar, which is equal to sigma ai xi by sigma ai comma sigma ai yi by sigma ai. Now I'm writing down the data once again here. So we have area 1, A1 is equal to 1000 millimeter square, A2 which is equal to 1000 millimeter square, and A3 which is equal to 1200 millimeter square, C1 x1 comma y1 which is equal to, we have this one 25 comma 60 millimeters, and C2 x2 comma y2 which is equal to 40 comma 25 millimeters, and C3 x3 comma y3 which is equal to 70 comma 15 millimeters. Just substituting all the values over here. See, I have already written the formula over here. X bar which is equal to sigma ai xi divided by sigma ai yi divided by sigma ai. But here, while expanding the formula, just you have to keep in mind that there are totally 1, 2 and 3 rectangles. Now when there are 3 rectangles, x bar will be equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3, and y bar will be equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Now writing all the formula and substituting the values in that one. X bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So a1 is 1000 multiplied by x1 is 25, a2 is 1000 multiplied by x2 is 40, and a3 is 1200 multiplied by x3, which is equal to 70 millimeter divided by 1000 plus 1000 plus 1200. By calculating, we'll get the answer as x bar, which is equal to 46.56 millimeters. Now to calculate y bar, we already know the formula. Y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So I'm just substituting the values. A1 is 1000, y1 is 60, a2 is 1000 again, y2 is 25, a3 is 1200, y3 is 15 divided by 1000 plus 1200, that is a1 plus a2 plus a3. And by substituting and calculating the value of y bar, we get y bar is equal to 32.18 millimeters. Finally, x bar comma y bar, the coordinates of centroid for the given section are 46.56 millimeters and 32.18 millimeters. Thank you.